Hello everybody, welcome to H&H Express, the Tuesday live stream. Welcome everybody. Just let me know if you hear the sound and if everything is okay, video wise, because it's still bright behind me, so thank you for letting me know in the chat. Thank you, thank you. Sound and vision is fine. Hope everybody had a good weekend. Okay, John says the sound is good, so video is bad. Let me put my other glasses on, just one moment. So, hope everybody had a good weekend. At least my wife and I did. So, let's see who else is in the chat. I saw the closet branch very early coming in. Welcome, the closet branch with upcoming baby. Which baby? I don't know if he's still in there. I see John Beniki. Welcome, John. Glad you could make it. I see Andy from the Hot Dog Pilot. And I see, let me see who else is in there. I see Peter Jackson from the Cheadle Heat. I got a message from Tom Houston Model Trains, and he could not come here, so unfortunately. I see Ivo van Zon. Welcome, Ivo. Hope you're doing fine. That's actually everybody in the chat. So it's a small crowd. Let me see how many are in there. I see 10 people in the chat. Maybe some are lurking in the background. That might be it. But that's fine. That's fine. So, hey, I see Mick92. Welcome, Mick. Glad you could make it. Yes, fine. Building kits mostly. Okay, very good, very good. Anybody else did any good thing this weekend? Because, yeah, as I already said, my wife and I did. And I will let you show. I will let you show. Let me see if I have the right one. Let me go to studio mode first. Yes, that one. So you should now see a puppy face. So that is maybe this one is the one to be, but you never know. You never know. So we'll see how that goes. Hello, Mons from Monsville Railways. Good morning to you. All the way from Australia. And John Beniki had a NMRA regional convention that went to the campground and went to the campground with the wife and the kids. Okay, had a great weekend. Still looks like sweep. I think you mean weep, sleep. Let me go back to that one. So thank you, John. Well, I have another picture. Let me put that on top. Where is it? Did I stop it? Let me move that up top. Because this was me. Okay. Mons, with Mons it's 7 minutes past 4 o'clock in the morning. So yeah, we were able to cuddle with the puppies. So that's yeah, that was very nice. 4 in the morning, screw it. Yeah, who knows? So yeah, John, with you, it's okay. So you're at Eastern Standard, John. Well, here it's 8 o'clock in the evening. So that hello, Chopperton Junction. Welcome to the stream. Glad you could make it. And in the UK, it's 7 p.m. So yeah, it was very nice. This was the first meet with the puppies live. So I do have other pictures, but you will see them. And if you're on Facebook, I have some pictures over there as well. So let me go back to normal mode. So yeah, so it was very good, and yeah, also a little bit emotional because of what's gonna happen. That around June 8th, the puppies will find their new homes, and there are 7 in this litter, so 7 families will get will get a new puppy. Okay. So Mansville is not sleeping, so thought I jump in. I think that's that's in here. Thank you. So yeah, so that was very nice that we were able to do that. So, what did you see in the thumbnail title? It's a new month. It's May. So we are heading towards. It's still gonna take at least 1.5 months to summer period. So, but Peter, yes, we have a name for it, but we're not letting you guys know yet. Nope, no, not gonna do that. It will come eventually. So, but we have a name, but I'm not gonna mention it yet. So the official breeder's name will be different than the call name, what we're gonna call the dog, because so. But yeah, that's how that is arranged in the pedigree. They need to put in the names, and then the chipper comes. They get a chip around 7 weeks, and then it's all in the pedigree. And but the new owners, they can give a call name. It used to be previously that many years ago that the new owners could choose a name for it. But a lot of breeders, they need to give the name already. Hello, Anthony. Oh, you just missed it. But you probably already have seen it. Months, that will be around June 8th. So that's another 5 weeks or 4.5 weeks. Because they turned 3 weeks last Saturday. So, but let me is it this one? Yeah, that's that one. So let me move that one over for Anthony, because he joined in a little bit late. So this might be the one. I'm not saying that it is the one, but we were puppy cuddling on Sunday. So I also have a picture of myself with him. Oh, where is it? Let me put that one on there. So yes, this might be the one, but yeah, of course there are 4 male dogs and 2 female dogs, and we are going for 5 male dogs and 2 female dogs. We are going for a male, and that was already mentioned when we met with the breeder. So yeah. Let me transition that back. So, yeah, let's see how that goes the coming weeks. We will be visiting the breeder again in 3 weeks. Yes, indeed, small puppy, a huge dog. A golden retriever is a medium-sized dog. It's not a huge dog, but they are between 35 and 40 kilograms if they are full weight. And you need to calculate it yourselves in pounds. So, what I wanted to do, but I see that I had hoped that Dave from Scott Rails was also in, but because I wanted to show him something as well. He had made I don't know if you have seen the video for his coaches, where he put the keep alive, or sort of keep alive, that was more that when the coaches are running over his turnouts, that the contacts could vary or flicker the interior lighting. So he created he used a resistor, a bridge rectifier, LED strips, and also capacitors. So I thought, you know what, I'm gonna build a little bit on a breadboard like this, which is a bridge rectifier. It has 4 electrolytic capacitors. It has a LED and several resistors. Yeah, electronics, yes. You saw it. So, and I also provided him some information. He used sort of the LED strips, except for these ones, they don't have any dropping resistors. But he put the capacitors in the back. And he was also wondering in the beginning why the capacitors need to be in parallel instead of... Hey, there we have Dave from Sprue and Glue. Welcome, Dave. So, hope you're doing fine. So, for you as well, I'm gonna let you see this picture. And there we have Newlyn Railway. Welcome, Newlyn. We went puppy cuddling on last Sunday. So this might be the puppy which we're gonna get, but who knows? So enough of that. So, but that is something what I actually wanted to do, and also the power section. It's getting along. So a little bit of wiring done, but you will see it later. Let me position that one here already. Yeah, thank you, Anthony. I also posted that on Facebook with some more pictures and also a small video. So let me see, where is it? So this is the. Let me see if we can turn it a little bit. Don't get dizzy. Thank you, Anthony. Okay, yeah, I know it's so, but this is how far I got with the new build. It's a lot of work because of the wiring towards the motor drivers. So I'm not gonna work on that one today, but I still have some wires to go for this section over here. So the fuses are on top, and then at the bottom you have your wires, the wires which go to the feeder wires of each track, and it goes through the current sensors. So as you can see, I only hooked up 3 current sensors at this moment, but there is nothing here. So I still want to have this section up and running first. Well, this is a little bit better than what it is underneath my layout at the moment. Tony, under the layout, it's all wires crisscross everywhere, and I thought, you know what, I'm gonna do it a little bit better this time. Let me move it a little bit up. Tuck these away. They will be, that is just 5-volt ground and the track power, and then the 5-volt and the ground will go to each component here and each component here, so that this one has power of the 5-volt. Everything is on the 5-volt rail, and I will have a left side and a right side. These wires are still a little bit loose, but I will put that one. Is it true that twisting wires together is better for conductivity? Well, it's better for shielding. It doesn't produce a lot of interference. The conductivity is just the thickness of the wire, so that it. But if you twist 2 wires, especially if you have AC and you are using it in a radio, for example, if you do AC wiring twisting, then it doesn't produce the fields around the cable. It neutralizes itself, at least a little bit better. And I'm doing twist those here just to make it neat, so that that I know that these wires belong together. It will have a block signal on it for pulsing, for the speed, of course. Hello, Floyd Robinson of Robbins. Welcome to the stream. Glad you could make it. So, but yeah, that is what I do here. So that's easier. But it's not for conductivity. So I still need to do these 3. So another set of 6. And then this section is done. And then I'm gonna hook up the current sensors, and I believe I already showed you that with the current sensors I'm gonna use a triple connector, which will be put on here. There's one ground, one 5V, and then the middle one will go to the multiplexer, and the multiplexer sends it to my central station, which will be in the middle. So this will be mirrored to that side, and then later on I'm gonna tape the cables together so that they are nicely fit as well, so that I have a better overview. Then I have my control station here, which does the power analysis, and then underneath I have this sniffer for hello Sion, welcome to the stream, glad you could make it. Yeah, that's true. Better twist together than keep it tidy. Yeah, that is true. So, and what I use cable clips to hold the wires in. I just removed the nail and added screws in. So, for example, this one will go in here, and then will go underneath here, and then to the next connector, and then wire it. But that is something what I'm not gonna do today here on the stream. Just wanted to show you the progress of it, and I actually didn't make any videos of it yet. The video which I'm gonna make is scanning these first 12 current sensors, so that the current sensor provides the correct output. And what I'm going to do is I'm going to put the full power on it and zero power. Then I'm going to check the current sensors each, because they are always have a sort of a they are not always the same. So let's say this current sensor measures half a current, so 0.5 amps, then this could be 0.49 amps for the same voltage. So that is something what I'm gonna measure and test as well, but it's for the coming weeks. So let me clean this one up. Let me see. This one was for the video. Because the other thing what I had was this. And I will make a drawing of it, which Dave from Scott Rill used in his coaches. Let me take some whiteboard markers. So if you look at this board, then especially when you have trains moving backward and forward, and actually it can be used on a AC system as well. Let me see, did I miss anybody? Hey, I see Dwight from the Curly Express. Welcome, Dwight. How are you doing? Glad you could make it. So you have your input. So that could be AC or DC, doesn't matter. AC or DC. Because you have a bridge rectifier, and a bridge rectifier is actually 4 diodes. Let me see. This one. So this is a bridge rectifier, and the diodes are always pointing the same way. So when current is flowing that way, it's flowing that way. If the current comes from the other way, then it flows also that way. So, and then you have a return, and the return, in this case, when it comes, it's either that way or that way. So it's always coming positive here and negative here. So, and what I have here on the breadboard is four capacitors, and when Dave nope, no. Keep a close eye out. No, I did not get the puppy yet. It's a full wave rectifier. That is correct. And in this case, this one is a big one for 250 volts, but you can use it also for smaller voltages. And it doesn't matter if you use AC or DC. If you use DC and you put the plus here and the minus here, the plus will be still here. But if you put the plus here and the minus here, then the plus will also be still here. So I'm being mesmerized by all this electric trade talk. So yeah, so for DC, it doesn't matter which way you put it, because DC is polarized. You have a plus and a minus, but the bridge rectifier will cause it that plus and minus. So a full wave rectifier, as this is, because you have four diodes, will always make sure that this section here, especially the way the diodes are positioned, make sure that this one is positive and this one is negative, and the diode should then be in this position. So when let me see. Hey, Joshua W56. Hello, Joshua. Welcome to the stream. So in this case, and I see JD, Grandpa Rails. Welcome, Grandpa. How are you doing? Hope you had a good weekend. We will come back later on everything what I did. So, and so what I have here, I have four electrolytic capacitors, and those have markings. In this case, it's 1000 microfarad. But with usually with resistors, if you would add the resistors, you put them in series. But with a capacitor, if you would enlarge the number of microfarads, you need to put them in parallel. So that would mean that the electrolytic capacitors would be all, well, let me make this a little bit larger. And you need to see it actually as a bucket full of water. And so this is one bucket. Then I'm going to put another bucket in it. I'm going to put another bucket of water in it. If you would compare it with a bucket of water. Then another bucket. And then you have your load. But yeah, for LEDs, this is a yellow LED. With the LEDs, they don't have that high voltage here. So if I'm gonna put 12 volt here, 12 volt DC, then here at this end I would have a little bit over 11, almost 11 volts, because the diode itself also consumes the voltage. But I can't just put 11 volts on here, so I need to use a dropping resistor. And then I have the LED. This is an LED, so it will shine. And the dropping resistor determines the brightness of the LED. So, and I hope that my cable is long enough. Let me, yes, I hope it is. So this is a just a regular adapter, 12 volt DC in this case. So these are the two cables which come from the adapter. Let me see. So this would be plus and minus. So if I'm gonna connect, and as I said, it doesn't matter, just do it. You see that the LED is lit. If I'm gonna remove it, the LED stays lit until those buckets full of energy, because they are all filled, until that bucket is empty. If I'm gonna remove one of pair, then you see that the LED will go out a little bit faster. So the more buckets I put in, the longer the LED stays on. But it also depends on how much resistance there is. A LED usually has what is it, 25 milliamps or 5 milliamps, depending on which one there is. And when you have a bad, let me put it that way, it's easier for me. If you have a dirty track, then let me put that one. So I'm gonna charge it, and a dirty track. That means that the contacts for the coaches are flickering. Now you don't have any flickering of the LEDs, of the LED. If I'm gonna remove the buckets away from it, then this is what the dirty track does. And if I'm gonna add a pair of buckets, so those are these two, and in this case it's together 2000 microfarad, then I hope you can see it. The brightness of the LED drops slightly. Can you see that? Let me turn off the light so that you can see it a little bit better. So it drops a little bit faster. So the more buckets you put on there, the longer it keeps the brightness. So now it takes a very long time to get discharge from it. And as mentioned, it doesn't matter how I'm gonna position the wires, because of the full wave bridge rectifier. It turns it into the correct correct polarity what you need. Now I put two resistors down here. So let me bring it up close. This resistor is not connected to it, but this one is. So let me change it, because this resistor is 2 times the resistance than that one. This one is 1 kilo ohm. Let me move that one so you can see the difference. So let me put power on there. You see that it is already gradually lowering the intensity. And let me put the 2 kilo ohm resistor, or 2.2 kilo ohm. So I'm limiting the number of current which goes to the LED, but it also limits the brightness. And now it takes a much longer time, because the LED uses less current, so it takes longer time to empty the capacitors or buckets. Anthony, I don't have dirty track, just a dirty mind. So, but yeah, that's if you want to regulate the brightness a little bit more, you use a variable resistor, a potentiometer or a potmeter, or everybody is calling it, and you put it in between. But you need to be careful that you don't bring it to 0, otherwise the LED will pop, because the LED in this case runs out of 2.7 volts or 3 volts maximum. And then since this is 12 volt, it is still reasonable low, but still, if you put the 12 volt directly between those cables, the higher the resistors, it extends the lifetime of the LED. Yes, but it also lowers the intensity, because you limit the number of current going through to it. So so I can put them in series, so I have 3 kilo ohms with this is a science class. I think I'm in the wrong room. Yeah, but I thought I'm gonna explain it a little bit. So these are electrolytic capacitors. They have a polarity, so a plus and a minus. So that would be plus here and the minus there, all of them. And as mentioned, you need to see it as buckets of water. Let me remove the adapter. But this is one LED, and you can also yes, indeed, it's a trade-off. Yeah. But you can also use a strip, LED strip, and most LED strips, depending on which you buy, they have dropping resistors as well. Let me do that. So they have dropping resistors. Hello, John, Schuylkill River Valley. Welcome, glad you could make it. So yeah, I hope you like this a little bit, where let me go back. So where this is a little bit explained, and So if you want to, the best thing, if you want to regulate, you usually use a fixed resistor, for example 1 kilo ohm, and then in here you use a regulator and a potentiometer to regulate the brightness of the LED. And the lower the brightness, the longer it holds its current. Yeah, it's worth knowing and understanding this stuff. Yeah, you're welcome, Mons. You're welcome. So, and if you put AC on here, then the full wave rectifier will convert it as well. But 12 volt AC works a little bit different. And then the capacitors, they take away the wrinkle. So if you have AC, which is this, at this end here it is this, and then at the end of here it's rising, and then you have a wrinkle, then goes wrinkle, and it all depends on. So this is the zero line, and this is the zero line. So this is the AC, so it goes positive and negative. Behind the rectifier you have only positive, but you have dips, and then after the number capacitors, it all depends on how many capacitors you have. You only have a rise and then small wrinkles, and the higher the capacitor, the smaller the wrinkle will be. Yes, if you have DCC, so the DC signal is actually also just a positive signal, and it is pulsed. And here, at this signal comes the same way here, so it's also pulsed. And if I would draw it the same way here, then it drops, and then you have it, and it drops a little bit, because the electrolyte capacitors, they provide that extra power when there is no power. So you would almost have the same as here, but usually a DC, but this is the DCC signal, and there is a frequency on it, and actually with here, with the power section what I'm building, these are pulse width modulated outputs. So I have the same here. So if I would do this in a coach of my on one of my coaches, I get the same result, that it's almost wrinkle free. So so you can use it for DC, DCC, and AC. And it all depends on your DCC system, how many volts will be produced behind after the full wave rectifier. So hopefully that helps a little bit. So, but I saw that some people came in, and there was a question by, let me see, I thought it was Dwight. Let me go back a little bit. Hey, Steve Childers, I missed you. Hey, welcome, welcome. So glad you could make it. Did I miss something? Did I miss anything? Where is it? Where is it? I thought a question was made in regards to the puppy. I don't have the puppy yet. The puppies are just over 3 weeks old. But let me show you the puppy. Did I miss anybody else? Let me see. Thank you, Andy. Yeah, test will be Tom. Hey, Tom, you could make it. So you're back from the garage. And your dog ate your homework. Yeah, next session, next week, I'm gonna ask some questions. So this might be, I'm not yet, the puppy, but it might be. But let me show you the other picture. So that was me cuddling with the puppy last Sunday. So yeah. Thank you, John. So we still have to wait another a little bit over 4.5 weeks to get ours. So thank you, Dwight. My dog is my homework. Yes, there's gonna be exams. Oh, you need to order yet another bit for the Land Rover. Okay. So, but yeah, that's. But I thought, you know what? I'm gonna dive in a little bit deeper, and especially with the capacitors, the higher the microfarad value, the longer it will hold its capacitance. What happens when you come to class late? You get minus points. Thank you, JD. Thank you. Yeah, as I said, I don't know yet if it's gonna be this one, but at least we were able to get a little bit with him. And in 3 weeks' time, we will be there again. Then it will be 6 weeks. So now they were 3 weeks, but they are already pretty yeah, heavy, if I'm gonna put it that way. So but yeah, it's the higher the microfarad range, the longer they hold the capacitance. And nowadays you have the supercapacitor, which you see instead of batteries or rechargeable batteries. And because of shipments around the world, a lot of companies, they are afraid in regards to the hazardous situation on rechargeable batteries. So they replace them with supercapacitors. You see that in the computer world as well, where a supercapacitor is used instead of a battery. But those supercapacitors, they are 10, 15, 20 times more they have 10, 20 times more microfarads than the one I use, because in total on this board, these four is 4,000 microfarad. So yeah, I hope you like that a little bit of electronics here and there, and I use that as well in my layouts. If you want to make a stable sort of The best thing if for power supplies is that you have one which already has a regulators in it to get the power, because but you could use this one as well and then put a voltage regulator next to it, so that you have a good start, and then the voltage regulator will regulate the voltage until a certain level of voltage, like a 5 volt or 12 volt voltage regulator. So like a course in engineering, yeah. So, but yeah, I hope you you like this this bit. So, but let's see if oh, yeah, it's I turned off the light. Let me turn on the light again. Land Rover should be made by Ford, fixed or repaired daily. Let me turn. Oh no, that's off. Turn on the light, and there is light. Oh, it's way too bright here. But it's getting darker behind me. Let me turn this camera down. Oh, wait. Don't. Let me. Come on. Let me lower that back. So, so we didn't run any trains today. How can that happen? I had put the 1208 on the track, but I can still run it. So let me, where is my mouse? So I had put the 1208 over here, because I wanted to check the track. Let me see if it still wants to run. Let me see. I hear it buzzing. The camera is flickering. Just one moment. Gonna switch that one off. Should have made a copy of the diagram. Well, you can still do that. Or just rewatch, yeah. Let me restart the camera. Nope. Yep. Okay. Yeah, that is true. If you put the capacitors in, then the flashing effect will go away as well. Otherwise, you have the 50 hertz here in the Netherlands, and in the US, you have 60 hertz flash. Okay, well, see you later, Anthony. Hope Kian gets all the attention he needs. So at least that train is running. Let me run the other train as well. the shuttle train should run as well. So, but if you want, Floyd, I should say make a screenshot. Just make a screenshot of it. And in this case, I use as resistor to keep it the value longer, 2.2 kilo ohms. And the value of the capacitors is 1000 microfarad per capacitor. Oh, I hear that there is a train, that the train stopped. Yeah, snipping tool, go ahead. So hope you you have it. And this one is a diode, because I see that the light yeah, well, this is one which I recommended him to do as well. But let me turn off the light, because the diodes need to be positioned in this way if you're not going to use a small bridge rectifier like I have here. If you're only going to use 4 diodes, then the diodes are positioned this way. Yeah, that's why I turned off the lights. I'm gonna turn them back on. So otherwise it's too dark. But oh, let me see. There is a train which stopped. So let me try to get that in motion again. A snipping tool, is that something a rabbi has? No, he talks about Windows snipping tool. You can just start, if you click on the taskbar and type in snip, then you can start the copying tool. You could also do a print screen or alt print screen if you're on a computer, and then paste it into a Word document or in Paint. Okay, there it goes. So, but I hope you like this session, this live stream, in regards to how the this section of a Keep Alive lights works in a coach. I put it a little bit in big, but you can also buy smaller components to do that. So so yeah, it's those are the things which we all can use in our model railway system. And so I hope you liked it. I see that it's already 9 o'clock, so I would like to thank everybody for joining in tonight's stream. So next stream, let's see what we're gonna do then. Maybe we're gonna work on the train station area again. And in the meantime, I will be working on the power section to put the extra cables in. So thank you everybody for joining in. Let me see. Yeah. So with that said, thank you, and have a good evening, night, morning. For months it's morning, and we'll see you in the next stream. Thank you and goodbye. Oh, I missed the end screen. Oh, there it is. Thank you, Peter. Thank you. So we'll see each other again the next time. Thank you and goodbye. And if you not already did it, in the background, hit the thumbs up for me. It's good for the analytics. Bye.